Alright, yeah, welcome to this lesson, and we have to find the dy dx of this function, x to the power of sin x multiplied by ln absolute value of x. And we already know how to solve this kind of problem because in the last problem we solved the function x to the power of x, showing how to solve variable to a variable problem instead of variable to a constant problem. So now, how do we solve issue of variable to a variable? All we had to do was take ln of both sides of the function and we're fine. But in this case, we have two distinct functions multiplying each other. So let us pick our f of x and our g of x. So you can pick anyone for f of x and anyone for g of x. So let us pick the first one. Let f of x be equal to x to the power of sine x, and let our g of x to be equal to ln absolute value of x. So we know what this will give us as g prime. This g prime of x will give us 1 over x, and this is f of x. F of x equals x to the power of sine x. We can't easily solve this. So now what we said was that we take ln of both sides of the function. So now we cannot, let us have this function here we have as a function of y. So we have, let us assume here to be not y now. Let us put maybe h here. So we have h is equal to x to the sine x, and we know that this h here is a function of x. So now taking ln of both sides, we have ln h is equal to ln x to the sine x, and by the property of logarithm, this man can come behind the sign to become sine x ln x. So here become ln h is equal to sine x ln x. So now it's as simple as knowing that this is another product rule here, sine x and ln x, and we already know what ln h will give us, and ln h will give us this is already different now because we have to find not h again now but ln h. But ln h is simply 1 over h, the h all over the x, because surely this will take us to implicit differentiation because we have to differentiate both sides now. Why? Because the left hand side is not y, it's ln h, or it's not simply h, it's ln h, but we have to find the h all over the x. I don't know, we have h here, to simply be the h all over the x, but we have ln h here, so we can't disregard that because this is also a function we need. So and here by product rule, what it said is that differentiate the first one, keep the second one, plus keep the first one and differentiate the second one. So let us start. This will give us cosine of x if we differentiate sine x and keep the second one, plus keep the first one now and differentiate second one, that is what 1 all over x. So and this will be the h all over the x is equal to, because we have to multiply both sides by h. What we need here is the h all over the x, not 1 all over h. So here we have h into cosine of x ln x plus 1 all over x sine x, and this cancel out this. So we have the h all over the x to be equal to, what's our h to begin with? Our h was the question, x to the power of sine x. So we have x to the power of sine x into cosine of x ln x plus 1 all over x sine of x. So now this is the h all over the x, and which is equal to this here. So we have to replace that in this function when we are doing so. This is the h all over the x here, which is the derivative of this function here, and this one will give us L 1 over x here, but we already know what this one will give us equals to that. What is below? So let us apply our product rule here and see what we get. Apply our product rule for the entire function, which is dy all over dx will be equal to this is also equal to h, as you can see. So we have differentiate the first function, which is x to the power of sine x, differentiate the first function, and that gives us what we have here, which is x to the power of sine x into cosine of x ln x plus 1 over x sine x. That's it, and keep the second function ln x. Now you add that to the second one. Says keep the first function x to the power of sine x and differentiate the second function 1 over x, which is interesting. So at the end of the day, what we have is this x to the power of sine x plus this all plus x sine x plus 1 over x. That is what we get when we differentiate the function x to the power of sine x multiplied by ln x, ln absolute value of x. So thank you, and see you in the next lesson.